Here's the game plan. First, we'll tackle the basic problem these towers are built to solve. Then, we'll meet our two competitors and put them to the test, head to head. After that, we'll see how engineers decide which one to bet on. And finally, why this choice matters way more than you might think.
All right, so to really get this industrial showdown, we first need to understand the fundamental challenge they're designed to solve. It all boils down to the science of separation, or what engineers like to call industrial contact.
The name of the game here is a process called absorption. The easiest way to think about it is like dissolving sugar in your coffee. The coffee's your liquid and the sugar is the stuff you want to snatch out of a gas. So you bring the gas and a special liquid together, and you basically coax the unwanted molecules to jump out of the gas and into the liquid. Just like that, your gas is purified. It's a surprisingly elegant way to clean things up. So we know what we're trying to do, absorption. Now let's meet the two different ways we do it. Let's introduce our main competitors, the two designs engineered to make this whole gas-liquid thing happen: plate towers and pack towers. From the outside, they might look pretty similar, but trust me, on the inside, they are worlds apart. First up, we have the plate tower, sometimes called a trade tower. Picture this. Liquid is pouring down from the top, cascading from one horizontal tray to the next. At the same time, gas is rising up from the bottom, bubbling like crazy through the liquid on every single one of those trays. Each plate is like its own little mini stage where that crucial absorption takes place. And in the other corner, the packed tower. This design just throws the idea of plates right out the window. Instead, the whole column is just filled with what's called packing. We're talking thousands of small, specially designed objects that create this massive, complicated surface area. Liquid just trickles down over all this stuff, making a thin film for the rising gas to flow past, giving it continuous, non-stop contact. This is the perfect way to see the fundamental difference. A plate tower is like a staircase. The liquid moves down in these distinct steps. The pack tower, on the other hand, is way more like a rocky riverbed, where the water just flows continuously over this huge, uneven surface. So step by step versus a continuous flow. That's the key thing to remember.
All right, intros are over. Time for the main event, the operational showdown. Let's see how these two stack up when we throw some real-world engineering challenges at them. First up, a tough one. Some industrial processes need to run under a vacuum, where the pressure inside is super low. In that environment, any kind of resistance is a big problem. So which tower handles these delicate situations better? And the winner of this round is the packed tower. Think of it like this. Imagine trying to blow bubbles through a really thick milkshake versus just blowing through a straw filled with pebbles. The milkshake is way harder, right? Well, forcing gas to bubble through pools of liquid on plates creates a lot of resistance, what engineers call a high pressure drop. The more open path in a packed tower offers way less resistance, making it the clear champ for vacuum systems. Okay, next challenge, foam. Some liquids, when you shake them up, create a ton of foam. That can literally choke the whole process inside a tower. A huge headache for operators. So how do our contenders deal with it? And it looks like the pack tower takes another round. It's actually pretty simple. All that violent bubbling on each plate in a plate tower, it's basically the perfect recipe for making foam. But the gentle, trickling flow down the packing material is way less likely to stir things up, making the pack tower the hands-down favorite for dealing with foamy liquids. All right, let's talk about toughness. These towers often have to deal with extreme temperatures, rapid heating and cooling. That can cause materials to expand and contract, putting a ton of stress on the structure. So, which design is more durable? And the plate tower finally gets a point on the board. Yes, the solid welded-in structure of the plates makes the whole tower naturally tougher against that kind of thermal stress. But it's not a simple win. Here's the trade-off. Because packing can be made from a huge variety of materials, ceramics, plastics, all sorts of metals, a packed tower can be custom-built to handle incredibly corrosive chemicals. It's a classic engineering puzzle: thermal strength versus material flexibility. So, with all these performance factors swirling around, how does an engineer actually make the final call? Let's dive into the decision-making process. As with pretty much any big project, money is a huge factor. But here, the cheaper option isn't always obvious. The answer really depends on one critical thing: the size of the tower. So here's the rule of thumb engineers follow. For smaller towers, maybe up to about 3 feet in diameter, a packed tower is almost always going to be cheaper. But As soon as you scale up to those really massive towers, the cost of filling that gigantic volume with all that special packing material just skyrockets. For the big jobs, it's way more cost-effective to just build and install plates.
So let's check out the final scorecard. Packed towers are the go-to for low-pressure drop, for handling foamy liquids, and when you need special materials to fight off corrosion. Plate towers are the champs when it comes to handling heat stress, and they're the economical choice for really big operations. See, there's no single best tower. It's always about picking the right tool for the job. Now, you might be sitting there thinking, okay, that's interesting, but why does any of this really matter? Well, in our final section, we're going to see how this simple choice between two towers has a massive impact, way beyond the factory floor. This quote really hits it on the head. Processes like steam stripping, which completely depend on these towers to work, are on the absolute front lines of environmental protection. They are a critical piece of technology for pulling pollutants out of industrial waste streams before they ever get a chance to be released.
And that really gets to the heart of it. When an engineer picks the right tower for a job like that, they aren't just thinking about cost or efficiency. They are making a critical decision that directly impacts the quality of our air and water. It just goes to show you, in modern engineering, top-notch performance and environmental protection are totally intertwined. These two tower designs have been the unsung heroes of the chemical industry for decades. But as we face bigger and bigger challenges, climate change, resource scarcity, you have to ask, are these old workhorses still up to the task? How will this tale of two towers need to change to meet the even greater challenges that are just around the corner?